Absolutely.
Okay, well, welcome everyone to September 2022 Aerobridge webinar. We have a very exciting webinar for you. If you are new to Aerobridge, what we're going to learn is some of the basics of the Aerobridge community. You'll learn a little bit about open skies, and more importantly, you will learn about how do you start thinking about assembling drones and so on. So with me, as a part of our regular webinar series, we conduct this almost every 2 or 3 months. If you're listening on a recording, you can go on a channel and look at the other recordings. With me is Vibhu Tripathi, and then some other people from the Aerobridge community as well who will join us. So let's begin with some backgrounds. Aerobridge is an open source project run by Open Skies. Just to give you some idea of what Open Skies does. It is primarily working on open source tools and products to support drone operations. This is something that you might find interesting. I just wanted to give you how these open source products are supported professionally. We have really two open source products. One is called Aerobridge, which is a community which would help you with drone design, manufacturing, management of the drone supply chain, things like components, tracking, and trusted flights, and so on, which we will get into. And then there is a UTM component as well, which is open source, which is called Flight Blender, which will help you with permissioning and has standards compliance and so on. As far as Aerobridge is concerned, Aerobridge is a community, as I said, and an open source project. You should, if you're new to it, you can go to aerobridge.io. There is a link to join the community Slack channel. We have about 100, 115 people there now. They will help you with understanding Aerobridge. If you're in India, you can get involved in the certification side and help around that. We make the server itself, which you may see in some of the previous demos. We have flight controller adaptations and modifications as well, which sort of are getting into the flight permissions and trusted flights as well. And then the focus of today's webinar is what we would call as open hardware stack and reference designs. So you might have heard of the Aerobridge F1 drone, which is a quadcopter drone measuring 1.5 kilos. So if you don't know about it, you go to aerobridge.io here, and at the bottom, you will see here the F1 drone, which is the quadcopter. You can see the details about our project and so on. But more importantly, this is the F1 drone, which is a drone mainly for basic mapping operations in the green zones, 1.5 kilos and a flight time of 15 minutes. And then these are the bill of materials. Now, this is the 2021 version of this bill of materials, and we are in the process of refreshing it this year. But the idea here is that we have these open hardware designs available for you to start building and manufacturing your own drones. In addition to that, the project has a lot of focus on trusted flights, which is basically giving hardware manufacturers control over what software can and cannot run on the drone, and the hardware is secured against the owner. So this should help you with the certification, with adding identity and authentication to your flights, and so on. So this is a little bit more detailed topic, which we won't cover today, but know that the Aerobridge community is working on trusted flights as well. Now, what we're going to focus on is this manufacturing and supply chain side of drones. Can you identify the components? Can you make sure how a drone is made and where it's made? And for that, we have basically a sort of what you would call as reference designs. These are drones that are built in workshops and small workshops that we're going to show you very, very quickly how that would work. And the idea is that by standardizing some of these components, you can then understand how you build and scale your manufacturing operations. So as you know, supply chain and inventory management is difficult for small sort of manufacturers. Part and component organization is difficult. Which part do you pick, which one you won't pick? And of course, where do you source these things from is also a very complicated question. And Aerobridge community tries to sort of help you with that by providing reference designs, by building that engineering expertise within the community. So if you're sort of new and interested in all of this, my sincere recommendation is go to aerobridge.io. There is a link to the Slack channel. apply for the form and join the community. And then you can start to get really understand how do you build some of these drones, and it would help you with your drone manufacturing operations, and by the way, compliance and certification and so on. And so essentially, as a part of that, as I said to you, we had a few, maybe 6 months ago, introduced the F1 drone, which is basically a quadcopter. And we had sort of shown you the components of it. How do you start to think some of the performance measurements and so on. And this is a drone that is specifically built for green zones and mapping operations in India. And as I said to you, it's about a 1.5 kilos. We're going to refresh that shortly. And as a part of this continual work, today we are going to introduce to you the N1 drone, the Nano drone, which is sort of the smaller version of it, a bit more lightweight and more exciting sort of applications as we sort of compress and condense the technology. So what we're really doing is with F1 and N1 is giving you the recipes to make a drone. What are the components and so on. And this is the website of the drone. As with all of these things, these are open systems. They are publicly available. Because the community has expertise in building these drones, we have sort of, we are playing with this and experimenting with some of this. So if you are interested in joining this in our sort of research and experiments, you're very welcome. But basically, the point of this is to sort of provide the community in general reference designs for hardware that are specifically suited for India. And then we sort of build out the manufacturing and the supply chain part, which is available in Aerobridge. So as I said to you, if any of these webinars and its content is interesting, the first thing to do is to join the community and then go deeper into this. That is the first step. What we are presenting is just a series of webinars around some of the introductory topics. You can go obviously as detailed as you want with this. With that, I'm very proud to introduce Vibhu Tripathi, who is the community lead in Aerobridge and has been there since the beginning. And he is going to tell us how do you start to think about nano drones, particularly small drones that can be built with components that are available. I'll just stop my screen sharing.
Thank you so much, Rishi. Can you also enable screen sharing?
I think I have it.
Yeah, okay. Thank you. So, hello, everyone. I will be talking about how we can assemble, how anyone who is very new to drones and who's very new to drone assembly can get started with assembling a nano drone. Although this is the first iteration, we'll be coming up with the subsequent iterations. We'll be making slight changes in terms of the flight time, as well as we'll optimize some of the things like the weight of the drone, as well as the performance of the drone. And we'll also integrate the drone with the Aerobridge server in the subsequent versions. So this is the first basic version of the N1 drone. So we'll start with what do we need? The bill of materials. The first thing that we need is the frame. So we are using the QAV 250 frame. It's a carbon fiber frame that is very suitable for building nano drones that weigh less than 650 grams. So the weight of this particular frame is somewhere around 120 grams. And with everything on board, the weight can go up to even 800 grams. If one can even mount a heavy camera on top of this drone. This is one of the high strength and high endurance frame as well. So assembling this frame is quite easy. It comes with a guide. You just need a 2 millimeter Allen keys and a bunch of spacers to assemble this particular frame. What we have also used is the Emax MT22 2204 2300 kV motors on top of this. So while adding the motors, make sure that you have the clockwise motors on the left side, on the left side of the drone. And just once again, just make sure that you have the motor orientation in the right in the right way. The motor one is typically anti-clockwise. The motor two is also anti-clockwise. Three and four are clockwise motors. So this is something one needs to take care of even while installing the motors. I'll talk more about the directions in the subsequent slide. The second thing that we need is a flight controller. So for this particular frame, we are using CUAV V5 Nano Autopilot. One can also use Holybro Durandal, or even Holybro 4, Holybro V5, and even CUAV V5 flight controller. But the reason why we are preferring CUAV V5 Nano is because it's compact, it's small, and it supports a lot of different peripherals. Like you can mount uh, an onboard computer as well as a GPS, and uh, a lot of different other sensors on top of this drone as well. So, and it also has triple redundant IMU sensors, triple redundant gyroscopes and accelerometers. And it has internal isolation as well to reduce the vibrations and to reduce the noise in each of those sensors. So it's a very high performant and industrial grade flight controller that we are recommending. I'll talk about the differences between these flight controllers in a second, but what we also need is a power distribution board. So you can use any kind of a power distribution board. What we are using is a Matek power distribution board, and the ESC that we are using is Emax 12 ampere ESCs. Yeah, and coming back to the flight controller. So uh, from left to right, the first one is the Cube Orange. It's one of the widely used flight controller that is even used in some of the bigger frames, some of the large drones that weigh more than 25 kgs as well. Pixel 4 is also a very light and compact flight controller, but the drawback of Pixel 4 is it comes with a separate power distribution board, and the cable management gets a little bit difficult, and it is quite difficult to add a Pixel 4 in such a compact sized drone. The third one is definitely the COBB Nano, and the fourth one is one of the flight controllers from Clean Flight. It is really one of the most compact and one of the smallest flight controller that is out there. The the plus side of this flight controller is the cable management is minimum. It's very lightweight. It is not much susceptible to vibrations, but the downside of that flight controller is it might not support GPS, although they do support GPS. But the feature of the GPS in these type of flight controllers, especially the smaller flight controllers, is only used for locating the drone in case the drone is lost. So the latitude and longitude positions are not used for localization of the drone. Those values are not merged into the EKF algorithm that is running on top of the drone. So one cannot use these flight controllers for mission planning and autonomous flying and waypoint following, etc. So yeah, so this is why we went ahead with the V5 Nano flight controller. The second is the power distribution. So this is an addition to the power distribution to that the first power distribution board that we talked about. The first power distribution board distributes the power from the battery to the motors and ESCs. This distribution this module distributes the power from the battery to the flight controller, the GPS, and all the different telemetry units that are on board of the drone. So there's a difference between the voltages. The first flight controller of the first power distribution board operates operates in the same voltage range as that of the battery. So it can be 11.1 volt, or even it can go up to whatever voltage battery that one is using. But this power distribution, the output of this power distribution module is limited to 5 volts, and in some cases it is also 3 volts. Depends on the flight controller or the onboard computer. The battery that we're using is the 2500 mAh 3-cell battery. It's 11 volts. Yeah, so the first step is always one should begin with integrating the ESCs uh, with the power distribution board. So make sure that all terminals are intact, and they won't uh, lose contact in case of a heavy vibration. So typically, one should use a good quality solder with a lot of coating and wax, so that uh, the solder remains intact. And also this try to secure these power distribution board from dust, because most of the time what happens is during takeoff, the thrust from propellers, it creates a lot of dust due to the heavy due to the the rotation of the propellers, and those dust particles, they get settled on these power distribution board. And once, if this gets unnoticed, sometimes what happens is due to heat or due to moisture, it starts dissipating the power, and there are certain losses that start occurring in these power distribution boards. So it's very important to make sure that does not settle. And also, most of the time, although in this case we are only using 11.1 volt, but if one is also dealing with large drones, the voltage in power distribution board can go up to 30 or even 40 volts. So yeah, this is how after soldering, all the electronic speed controllers would look like. The middle one on the left hand side is the input from the battery, and all the rest eight nodes are connected to the ESCs, to the four different ESCs. Yeah. So moving ahead, what one should also do is using a multimeter, uh, check that there is no check that the soldering is done correctly. Check whether there is no short circuiting, because soldering in a very at a very small 3 x 3 centimeter board is quite complicated, especially if you're doing it for the first time. So always double check with a multimeter that the negative and the positive terminals are not short circuited. And also connect with a battery and make sure that the voltage from the battery is same in all of the four different inputs of the electronic speed controller. Then you can place this electronic speed controller in the drone. And after placing it in the drone, the most important thing is checking the motor direction. So the output terminal of the ESCs, once you connect it with the motors, do not solder it without checking the direction of the motors. So you can temporarily connect all the three terminals of the ESCs with the motor and connect the battery. You can either connect the flight controller to the ESCs. You can collect the PWM PWM port of the ESCs to the flight controller, or you can also use a remote controller like FR Sky i6, or any Futuba, or any remote controller can also be used to test the direction of the motor and make sure that the motors are spinning in the correct direction. The motor one, uh, which is the top right motor, should always spin in the anti-clock direction. Motor two also anti-clock, three and four are in the clockwise direction. I'll also explain what this how 1, 2, 3, 4 is actually done in drones. This naming convention of motor 1, 2, 3, 4 remains consistent across all these different communities. If you go to PX4 or Ardu Pilot or Clean Flight, Beta Flight, they all have the same convention 1, 2, 3, 4. And yeah, so you can use QGC to, there's this option in Q-Gun control vehicle setup where you can check the motor direction. You can slide, you can use these sliders to, check the direction. And in case the motor is spinning in the wrong direction, you just have to swap the two terminals of the ESCs, which is connected to the motors. So once this is done, once all the connections are made, you can attach the GPS to the board, and you can add the battery to the drone as well. So this is how the drone would eventually look like. You can attach the propellers. You can do the initial test flight. You will be required to perform the IMU and the compass calibration. If you're doing it for the first time, make sure that the firmware that you're using is the latest. Currently, I think the Autopilot is running 4.3.2 copter firmware. Make sure that it is the latest firmware that you're using. And after calibration, you can do a small test flight. Make sure that you get enough satellites, at least 10 satellites before taking off. And of course, in the first takeoff, also ensure that there's a enough space around the drone. You should test it out in the open, and the space across the drone during a test flight should be more than 7 to 8 meters during the first few initial flights. Yeah. So this is it. I will also jump to some of the calculations and some of the other parameters that we came up with. So here's the list of materials, as well as the cost. The cost is in INR, and the weight of the total drone. So currently the weight is somewhere around 528 grams. We are also targeting to reduce this weight, and we are, slowly in the subsequent version, we'll try to get closer to 250 grams. Currently, there is a lot of redundant weight in this drone, as you can already see. The GPS is currently quite heavy at the moment, because the mounts that are used are metal mounts, and the cables are also extra large. So, the cable management is not done that accurately. And as well as other than that, I guess what can also be optimized is we can use 4-in-1 ESC. So currently we're using 4 different ESCs that are currently, the ESCs are, by the way, placed below each of these arms of the drone. And once we use 4-in-1 ESCs, the weight would get reduced by somewhere around 35 to 36 grams. Also, by optimizing the GPS, we can cut down the weight by an additional 35 to 36 grams. And then, slowly we are also, we can optimize the weight of the other components. And then I'm assuming by the next version, we will be able to cut down the weight by somewhere around 120 to 150 grams. So yeah, so if also coming to the flight time, so there's a website called eCal. So you can do two things. You can either calculate using the same sheet, the same calculation sheet that we discussed in the last time for the F1 calculation, or there's this very popular tool that is quite popular in the industry at the moment. All you need to do is enter the weight of the drone, select what batteries are you using. Like in our case, we're using 2500 mAh battery, which is in 3S configuration. The controller that we are using is, although it's 12 amperes, but the controller, selecting a larger controller won't affect much around the performance of the drone. The motors that we're using is Emax MT2200 and 2300 kV motors. Propellers are 5-inch propellers with the pitch of somewhere around, the pitch is actually somewhere around 0.5 inches. And if we calculate the thrust, no, it's not 0.5, it's 1.5, I guess. Yeah, so the thrust to weight ratio is somewhere around 1.5, which is good enough for a drone to hover in light to medium windy conditions, and it can travel at a speed of somewhere around 4 to 6 meter per second. The total flight time would be somewhere around 11 minutes, and this is for battery when when the battery is at 85% of discharge. If we consider 100% discharge, or if we use the formula of that we were using, the flight time would come somewhere around 12 to 13 minutes. But yeah, for safer side, one shouldn't let the battery go below 85, below 15% because it reduces the time, the life of the battery significantly. So yeah, this is it. For any other reference, you can join our Slack channel. We will be adding a few links to this video and some links to other website that we refer to. Like, there's a guide on how to do the motor setup on the Q ground control docs. You can also refer to the Arduino docs for flashing the firmware. There are multiple ways on how you can flash the firmware. There are multiple tools available as well. You can either use Q ground control or even the mission planner as well to flash the firmware. There's complete step-by-step guide to do the same. Make sure that you select the right frame after installing the firmware. And yeah, and in case you're using the clean flight or the beta flight, clean flight or the beta flight flight controller, you can download the Chrome extension. So the Chrome extension comes with an inbuilt configuration manager where you can set up all the parameters and you can update the firmware and do everything that is required to set up the drone. So yeah, that's it. I think Rashid, have I missed anything?
No, thank you. This was excellent. Basically, where we are right now is that we are going to refresh the F1 and Vibhu is showing the drone. Vibhu, if you can just just turn off my...
This is the drone currently. The battery is in between and the propellers are intact. I think I forgot to mention that the GPS unit that comes with the drone, it has inbuilt security switch as well as it has inbuilt buzzer. So as soon as we connect the drone to the power source, you'll hear different power beeps, and each of those power beeps signifies a different thing, right? So and even the LEDs, there it goes. That was a boot up tone, and even the LEDs signifies the different thing. So if it's glowing red and green, that means it's booting. If it glows yellow, then it means it is waiting for the GPS source. And if it's completely green, then it means that it has got the GPS lock and it is ready to take off. So right now, since I'm holding the drone, I have to keep it on a flat surface in order for this to initialize and calibrate the inertial sensors. And once that would be done, the drone would be ready to fly. I also forgot to mention about the telemetry unit. So the telemetry unit, so now it's growing yellow, so it's waiting for the GPS signal. The telemetry in this one that we're using is 2.4 gigahertz. I will not recommend using any other telemetry radios that are available because most of them are not legal in India, especially the 433 megahertz and 913 megahertz telemetry radios. The 2.4 gigahertz is legal. And one good thing about using 2.4 gigahertz is that you won't need a receiver at the other end. You won't need the receiver at the ground control station. You can just use your phone's Wi-Fi to connect to the drone. The range is somewhere around 100 meters if you are in the line of sight of the drone, and it works significantly well. So this actually comes out of the box. This actually comes along with the CUAV V5 Nano drone. Yeah. So
Perfect.
Over to you, Rishi.
Thank you. Yeah, this is great. As we said to you, what we're trying to do is to build some of the basic recipes for nano drones. We will be refreshing some of these, and the best way to know about them is go to aerobridge.io. At the bottom, you will see a link to the F1 drone, and now shortly after all of this is complete, to the N1 drone as well. And with that, we conclude this month's webinar. Again, thank you for joining. We will continue with this. If you want to look at the flight controller and the management server side, I would suggest you look at some of the previous webinars. We will be sharing more information as we progress. Thank you for joining. Bye.